Hello everyone, welcome to a brand new video on the structure of the glomerulus and the filtration membrane. This will be kept a little short, sweet, and to the point, but let's take a look at what we're seeing here. So we are going to look at the structure of the glomerulus. We'll look at the structure and some of the basic functions of filtration membrane. There will be videos following this later on with some more in-depth topics on renal physiology, but this will be important to understand and help us grasp what we're seeing. So what I want to do is get right to the meat and discuss our glomerulus first. And to do that, we need to draw the blood vessels that produce it. And to do that, I am going to draw one blood vessel a little small, and then one a little bit bigger here, and then we're going to produce a large mass here. So if you draw this with me, we're going to draw something that looks like this together. So we have this mass. Then what we want to do is surround this mass. And with a black line, then we'll come around and come around like that. Okay, and then we're going to draw a circle right here, and we're going to make that circle hollow inside. Okay, so let's take a look at what we just drawn. Let's label these things and let's discuss it. So starting out here, you have blood coming in, arriving to what is called the, and it's a little bit larger in diameter, is the afferent arriving arteriole. And the afferent arteriole, blood will enter to the glomerulus here. It will pass through and then come back out the efferent arteriole, efferent exiting arteriole. And in between here, of course, we have the blood vessel known as the glomerulus, which is made up of about 50 intertwined capillaries that form this massive mass called the glomerulus. Gets its name from its shape of a ball, mass of a ball. Now, also around it, we have what is called the Bowman's capsule. And the Bowman's capsule, Bowman's, or also called glomerular capsule, surrounds us. Now there are two layers to the glomerular capsule. There is a parietal layer to it, a parietal layer, parietal, and there is a visceral layer as well that makes this up as well. And inside between the two, the space here is called the capsular space. And the capsular space is going to collect that filtrate. Now, this guy over here, this would be your proximal convoluted tubule, and this is your distal convoluted tubule. As it folds over here. And it's important to know this generalized location as you guys try to comprehend and understand such things as regulation of GFR, the renin-angiotensin system, RAS, things like that. So what we want to make sure we have with this is if we were to go in with this guy and I were to pick right here and were to zoom in on this, what would we see? Well, we would see something that looked like this. And right down the middle here, I'm going to draw the basement membrane here. This represents a basement membrane, so we know we're going to have some kind of epithelium going on here. And the epithelium that is attached is going to be the endothelium of our glomerulus. So this is the glomerular endothelium. Now, endothelium, remember, is the lining of a blood vessel. But this endothelium has gaps, and these gaps are called fenestrations. Remember that the glomerulus is a fenestrated capillary. There is holes in it. There are gaps. And then with these gaps, and I'm going to grab here and change color. I'm going to try to find a good, let's go for this color here, this color of lavender. And I'm going to draw the other side of this guy here is something that looks a little like this. And I could leave some more gaps, but I'm just kind of drawing it very accentuated here. And I'm drawing what is called the podocytes. These are specifically the things sticking out of the podocytes called the pedicels. And then in between the pedicels, the gaps down here are the slits. And together, this produces a filtration membrane. Now, what is a filtration membrane separating? Well, on this side, we have the capsular space over here, and that's where filtrate will end up being produced. And on this other side, we have our glomerulus. This is the capillary, oops, there we go. Let me get that a little bit better. This will be the capillary lumen. And so this will be the capillary lumen, the internal. Now, something I want to add here, and I find that very important that we do discuss this, is so here we have a protein, plasma protein. So we have a protein here. And this protein, you notice, if it tries to get through the fenestrations and these slits, it can't. So what we're going to see is our filtrate should be protein free, as it produces some basic filtrate free of protein. So what you're going to see is this little proteins, they can't enter through this. It makes a very fine mesh filter, a slit that's driven purely by capillary hydrostatic pressures that are pretty great, because in the capsular space, I just want to mention that capsular space here, you're about 300 milliosmoles per liter. And in the glomerulus, you're about 300 milliosmoles per liter. Since they have equal osmolarity, the osmotic pressures are equal. So there you all have now is the glomerulus' very high capillary hydrostatic pressures that will force fluid across this fine mesh filter, producing filtrate. Okay, and that is your overall basic function. Now I'm going to get into about regulation of things like GFR and other urine formation processes in a video series that I've been trying to get started. But this really concludes the basic foundation to understand the glomerulus and its filtration membrane. I'll do some other videos looking at the renal vascular pathway, the nephron and its physiology and all that good stuff as well. So with this concludes our video on the filtration membrane and the glomerulus. And I hope you guys draw it with me. I hope you find these useful. There'll be other videos coming soon on these topics, but thank you and have a great day.